Okay, what I did was I started my cluster. It's not a cluster anyway, it's a single node. So I started my Unix server. I reformatted that HDFS. Okay. How do you see that HDFS files? Hadoop has its own commands. Okay. They are similar to, they are actually Unix commands, but you have to prefix with Hadoop ./Hadoop. You have to run the Hadoop thing, then you issue commands. The commands are almost similar to Unix one, but there are about 15, 20 plus commands, not that many. Okay, the basic commands to list your files, copy files, copy from local drive, copy to local drive, because HDFS is you cannot see by just typing your Linux commands. So you have to go to the HDFS area because it has its own file structure, then you issue your commands. Okay. For example, I want to list all my directories in my HDFS. So I have to type Hadoop fs -ls user input. This is my directory /user/input is my input directory on my HDFS. You cannot see it using ls -l or whatever on your local system. That's a HDFS one. Okay. The file stored on this HDFS directories, you never know whether it's locally stored or stored across nodes. Remember, we have that replication factor. It may be saved in one chunk here on locally and one chunk in node 53. We never know. Okay. But since we are having only one node, we know that it's locally saved somewhere, but you cannot use the local commands to see that.
Yeah. Does that mean when you do a copy, we list it, we see it, but it actually may exist in any number of other places at the same time?
Exactly. Yep. Okay. If you are having a cluster, if you are doing an ls and a particular file, maybe one chunk is sitting here and another chunk is sitting somewhere else, but you will see that actual file listed locally. You know what I mean?
But by doing that, you'll find everything.
Correct.
Right.
So the name node will know where that the file is. All the chunks are saved. It will combine and it will just list it. Okay. So here there is one text file test.txt I saved into my HDFS. Okay. And this user input you cannot see it here locally on your Linux system. I cannot say ls/user input. It says there is no file or directory because it's a HDFS directory. Okay. So you have to use this HDFS command. This is a HDFS file system command, but again it's ls only, but you are running inside the HDFS.
Is the same thing true if you try to list the output directory as well?
Correct. Yes. Yeah.
So that's how you know the job is done or something, because it shows up there. Or?
Yeah, it shows in you can create a separate directory. Let's say you are processing one file, you can create a separate directory. Under each file, it will create a directory under HDFS, and also the output files are actually saved in parts. Actually, part file. Part 0, part 1, part 2, 3, da 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 da. Okay. So and also you never know that part 1 is actually sitting on this node or somewhere else, but it will list this many parts available. When you are opening, when you are reading that particular part, it may be reading from some other node.
But can you if you go to the name node, can you tell?
No, it's a binary file. You cannot see it.
Because it said that name node, it had
metadata, right? Yeah, metadata you cannot see. It's a binary. It's own format.
Oh,
Only
listed.
only name node will know the information. Internally, it understood.
You're actually looking at the name node here, right? I mean, isn't that what you're interfacing with right now?
Yeah, only this computer.
Other nodes
Other
are,
nodes are not exist in this setup.
right.
I'm using my laptop as a name node, data node, everything. So, but let's say you have 5 other nodes. It will be displaying the same thing, but you never know one chunk is coming, where it is coming from, whether node 5 is coming from or node 3 coming from, we don't know.
But where this information will be, so it will be hidden somehow?
It's metadata in the name node, only understood by the HDFS process. We cannot just query it name. You cannot. It's internal to HDFS. Yeah. Okay. So this is the input file. I just want to view that one test dot. So this is my local directory, right? So from here only I copied to my HDFS. Okay. That's a simple text file. I just type something, Hadoop used to process large data set, blah blah blah. Okay. So I want to count the distinct words in this file, and I want to see the output. Okay. Each word, how many times it occurred. Okay. For HDFS, you have to define the input file structure, but for the output, you do not need to create the actual file structure. It will create by its own. For example, you are copying this test.txt onto HDFS/user/input, right? That /user/input you have to create a directory for input files. But when you are processing, you have to specify the output files where the result should be stored. But that one you do not need to create beforehand. The process will create for you. Okay. So now I am going to process this file. Okay. So this is the command Hadoop jar for the Java process, and this examples jar is a collection of Java files, right? So we have different classes for various processes. We have all the Java files. So I am calling from this Java jar file, I am calling only the word count class, only one piece of information, right? One piece of program which does the counting of the words. Then I am specifying the input. What is my input? Is test.txt, which is sitting in the user input on the HDFS, correct? Then this is the output file I want to create on the HDFS, user output test. So each file it will create a directory. Then under the directory it will create part 1, part 0, part 1, part 2, depending on the output file size. Again 64 MB bits.
In other words, you actually have to create a jar file first.
I'm sorry?
You have to create a jar file
Exactly, yes.
before you can
Correct.
go to HDFS.
Yes. The jar file is depending on that is actually your development of what you want to do, what type of operations you will be doing. Here we just want to count the words, but if you want to do something else with some other file, source file, you have to come up with your own jar file or another class under the jar file. Okay.
Now, you mentioned before that you don't do Java development. How is there just a different team that's doing this, or where's the jar file coming from if you're not creating it?
Well, in Java there are thousands of classes are available for almost all the operations. Somebody developed and saved in libraries. So you don't have to recreate the only thing is you have to know which file you need to import, that Java jar file, the libraries you need to import. So it's all pre-built, it's available already. The word count is already written by somebody, and it's actually saved as a public library. So you can import it. If you open that jar file in the Java program, it may be importing from somewhere. Okay, you will be using some other existing Java program. Only thing is you need to know for which operation, which class you need to use. Okay. For word count, everybody knows that okay, this is the existing tested program which is available for anyone to use. Okay. So you are calling that program. Okay. For random numbers, for basic operation, top 5, bottom 5, you have classes already available. Okay.
There is a standard source code for word count. Java program is source code
Mm-hmm.
for all word counts.
Source code for this word count.
Yeah, for word count, yeah.
Yeah, it is sitting in the, it is actually sitting in the jar file, which is like a execution type of file for Java. Okay. But if you open a jar file, you cannot open and modify anything, right? It's an executable. So that uses the original source code, which is from the public library. Okay. Yeah. So you can standalone, you can use it because that is already imported, developed, and made as a jar file. So you can port it anywhere and just start doing it. If you want to make modification, you have to refer to the original actual Java code, and you just change it, and you save it locally and create your own, generate your own jar file and start using it. Okay, it's like a public library or something kind. Okay, so I am processing this. Okay, so my output is already exist. So first I want to remove it. Okay, I am running a job. It's actually a mapper and reducer, as we discussed in the bear car driver example. The same mapper will map it with a key value pair, then reducer will aggregate the value, and it will write to the /user/output/test. Okay. You can actually cat here, sorry, not directly. So this is the output directory. So I have this part R 501 file, okay, because it's a small file, right? Small input file. Okay. So there is another way to view is you can go to the browser. So this I just name it as local host. So you can name it as, if you have a multiple nodes cluster, you won't be calling it as local host, the actual host name. So file system, user, input and output. This is what we created. This is something the process created, right? So input, we have only one file, which is test.txt, which we copied from the local directory to the HDFS directory. The content is this, right? Now check the output file under output directory. These are the HDFS, is not reading from local Linux directory. This is the, these are the log file, so you don't have to worry about. If you want to If you see a failure or error, then you can see what is wrong in that. Otherwise, you can just check that output file. So this is the output. So each word, how many times it occurred in that input file. So you can verify it. Okay, Hadoop twice, MapReduce once, and so on. Okay, here you see this data twice, data comma once, data full stop is once, and so on. So this is the basic program used for weblogs reading to see how many how many users accessed your website. All the Google Analytics use the same word count. Okay, a lot of programs are used by this word count. It may look simple, but the base is this. Okay, yeah.
So if you want to like change the business quotient there, like for example the maximum word length, do you have to go to your jar file and modify your source code?
You can come up with your own logic. If you want to, okay, let's say my input files will be like this, and I want to process like this. So you have to come up. You need to know Java. In that case, either call or import the existing Java file, or you come up with your own. Usually we go with the existing ones because we don't want to spend that much time writing again and again the same thing. Only thing is you need to know whether your logic is already addressed by someone, already programs are available, okay, or if it is available, part of which class. Okay, so you need to just reuse it. That's it. Okay. So any questions on this Hadoop second session? Any questions related to big data? Big question, small question, medium question, variety of questions.
I was just thinking about when you describe how data is being distributed, and I was just thinking another similar to that on the hardware side would be if there's an implementation of storage like a read file, the way data would be distributed among the different hard disks. So is that something similar to, or does that draw parallels to how the data is stored?
Well, it's a similar distribution, but it uses its own own way of distributing files, own way of reading files and writing into nodes. But the very high level, yes, they are similar distribution, similar to RAID style. But when coming to processing, it's entirely different. That's where it makes a difference. Yeah.
So, for the Hadoop, the framework, what type of industry, meaning to say the site, would you recommend, or are you seeing that is appropriate to invest in this type of app?
I think I've thrown a couple of examples, like Google. When you are typing something in a Google search engine, it starts giving some suggestions. Google is already using big time. Yahoo is using. Facebook is using. So there are thousands of MapReduce jobs are actually running in the background.
Right, so those are huge companies. So if you are a small to a mid-sized company, would you say appropriate to invest in this type of thing?
Well, there are okay. If you are looking for the business opportunities, then we can discuss one-on-one. I have some ideas to share, but just joking. Small companies, yeah, definitely they can come up with their own product. There are a lot of companies already doing this, because weblogs, server logs, companies actually releasing their own product. Okay, this is our product where if you have in your enterprise you have 50s of or hundreds of servers, we can collect the logs and analyze it. You can send a report. You know what I mean? We can actually see how many people from foreign countries or from within US try to hack your server. How many how many times it's being phishing attack occurred. It's all these things. How many times it's failed? How many times it running below that the capacity? Whatever you can collect from the log, whatever you can analyze, you can send us a report. Because if you are a network guy, the logs are not really user friendly. But I don't know. I'm talking about a bit older days. But now, using these tools, you can actually come up with really good data visuals, which we'll be covering in the next session. You can visualize the data. Okay, this many attacks coming from this country, this many intruders, this many times failed. So it's easy to monitor and plan for the future. So there you see a business opportunity. Small companies, they can come up with their own product or big data based services. Yeah. So yeah.
I just want to make a contribution towards that. And I think big data can be used in any company so far. Like even in census data. I mean, these are log files like you're saying. And these are files you can process using big data. All you gotta know is how to transfer this data from the RDBMS into Hadoop. When you do that, it's more efficient and more easier to execute than using the RDBMS. So
Well,
the point here is, it doesn't have to be unstructured before you can use big data. You can even use big data and use unstructured data. But you just gotta know how to kind of really transfer these files.
yeah, we discussed about big data being complementing the existing data warehouse, right? Definitely don't replace it. What big data technologies can contribute, in which way they can process the unstructured or semi-structured or non-structured unstructured or semi-structured data. Actually, there is one data warehouse tool for big data called Hive. Okay, Hive store data in a data warehouse structure. Okay, so you use the normal MapReduce process your unstructured data or images or whatever variety of data you have. Okay, then you store into the Hive data warehouse. They're somewhat structured, okay, in a database manner. We call it as a NoSQL. NoSQL means it's not like you're not using SQL. It's not that meaning. NoSQL is not only SQL. So these kind of databases are related to the big data. Okay, so they call it a columnar databases or unstructured databases. So once you store into those databases, then you can combine this data with your normal RDBMS and come up with very effective reports and data visuals. Okay, so you are adding value to the existing data warehouse. But the only difference is you will be in big data area, you will be processing the unknowns, you will be processing the unstructured data. So that's where the value addition is coming. Your existing data warehouse, you are doing some value addition, you are storing somewhere after processing all this. Then either you are combining these two, or you will be transferring the unstructured columnar database data into your existing data warehouse. Then you do a normal processing and data visualization. Okay. Yeah. Go ahead. Mark. Yeah.